Up and away in my beautiful balloon. Miss Ricketts here, and we're going to be doing a little investigation with balloons. So stay tuned and remember, the world is your laboratory. Today we'll be reviewing experimental design with Alouds. So let's begin with some picture vocabulary. Our first term, experimental design, is a type of investigation used to test a cause and effect relationship between two or more elements. If I had to rewrite this and state this in my own words, I would start with the stem. Experimental design is the process or way scientists conduct experiments. Testable question. A testable question is a question that can be measured and observed through experimentation. In my own words, I would say a testable question is, or ask the question, what are we trying to find out? Variable. Variable is the one thing that we set out to change in the experiment. In my own words, in my own definition, I would say it's the one thing that is different or the one thing that I'm changing. Everything else must remain the same. So I'm looking at this picture and I see three plants and they're identical. They're the same plant. Plant 1, plant 2, plant 3. And I'm looking at the suns, and the suns are identical in each plant picture. But I'm looking at the water, and the first plant we're giving absolutely no water to. The second plant, we're watering it every day with 20 milliliters of water. The third one, we're watering also every day, but with 40 milliliters of water. So the one thing that we're changing, the one thing that is different, is the amount of water we're giving the plant. I wonder what my testable question would be in this situation. I know it's going to have to do something with the amount of water I'm giving the plant and the relationship to probably plant growth. So my testable question would be, does the amount of water affect a plant's growth? Since the amount of water is the one thing I'm changing. It's the variable. Here in this picture, I'm looking at ramps. And I see all of them are cardboard. All of them are made of the same material. But I see the first ramp has 2 books. The second ramp has 4 books. And the last ramp has 6 books. Everything else is the same. So the one thing that's different, the one thing that I'm changing is the height of the ramp. That's my variable. Constants. The constants are the things that are the same, the parts of the experiment that stay the same. The things that stay the same in this experiment are the cardboard ramps, the car. Everything else changes. And of course, repeated trials. Conducting an experiment at least 3 or more times to verify, to double check, to be sure that the results are accurate. So if I had to use the STEM, I would say scientists conduct the same experiment over and over and over again because we want to be sure. We want to double check. We want to verify that our data and our results are accurate. So let's look at the elements of experimental design by making a balloon rocket. And you tell me if you can find out what exactly I'm testing. What's the one thing I'm changing? What am I trying to find out? Are you ready? Let's look at the materials. I'm not going to give everything away. String, tied from chair to chair. Straw, threaded on the string. Balloon. Balloon pop, so I can get the same amount each time I do it. Some tape and my trusty tape measure. Let's go. We're going to do 10. 5, 6, 7, 8, 9, and 10. Oops. 10. That's about 10. Get some tape. Let's see if I could do this with one hand. That's why we need to collaborate and have more than one person do it. But hey, we do what we can in science, right? I'm starting it off right here. Tape. Here we go. We're going to launch it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Woo! Wow! That was 1 meter, 2 meters, 3 meters, 4 meters. Wow. Now I did it with 10. Guess what I'm going to do now? I'm going to do it with what you see. Hold on, put my mic. Thank you, producer. Same balloon. Same balloon pump. Same mic, I hope. Here we go. What am I doing differently? 3, 4, 5. Have you figured it out yet? Don't tell. Can't tell. Tape, tape, tape. Tape, tape, tape. Ready for launch? Watch the cord. Ready? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh, we have 1 meter and a half, 1.5 meters. What did I do differently? And what was I trying to find out? Now, let's have some think time. What was the one thing I changed? What was the one thing that was different? Let's think about that. Let's use our sentence stems. The one thing I changed was, or we can start it off with, the one thing that was different was, now think back to the video that we just saw. And what was the one thing I changed? The one thing I changed was the amount of air in the balloon. The first time I gave it 10 pumps. The second time I gave it only 5 pumps. I changed the amount of air in the balloon. And remember, I can only change one thing. Everything else has to stay the same. Everything else stayed the same. The balloon, it stayed the same. The actual air pump was the same one I used. The string was the same. The tape measure was the same. The straw was the same. The tape was the same. Everything else was the same except for the amount of air in each balloon. So let's look at this testable question. What is it I'm trying to find out? And you know it has to do with the amount of air and the relationship between the amount of air I put in the balloon and the distance it travels. So, if I were to say it in a testable question form, I would say, does the amount of air in the balloon affect the distance it travels? And remember one thing that would have made this experiment even better, more scientific, would be to conduct it over and over and over and over again, repeated trials, to be sure, to double check, to triple check, because we want to have accurate, reliable data. Now let's do a little hands-on investigation that I call Roll, Baby, Roll. So we're still looking at experimental design through the eyes of force and motion. And I've got 3 sit-ups here, and I want you to think, what is being tested? What is my testable question? Here we go. Let's look at the first setup. I've got these books here, a ramp, and my little yellow car. Setup number 1. Let's go over here. Ready? Setup number 2. I've got these books here, my little yellow car, and a ramp. Setup number 3. I've got this book here, my little yellow car, and my ramp. And of course, I have my trusty metric measuring tape. What am I trying to find out? What's the one thing that's changed, and what am I testing? What's different in each one of these, and what is the thing that's the same? I'm going to give you some think time to figure it out. Ready? Did you get some think time? Some more you need? Okay, here we go. Picture number 1, setup number 1. I'm looking at all these, and it's the same exact cardboard ramp. Whether it's this picture, come over here, this picture, or this setup. And I notice it's the same card that I'm using time and time again, and the same type of book. But wait, how many books do I have here? 3. How many books do I have here? 2. How many books do I have here? 1. That's right. The height or the number of books is the one thing that I changed. So I know that my testable question is going to have to be with something about the height of the ramp. So if I had to think about it, I would probably say, does the height of the ramp affect something? I have my tape measure here, and I know that my tape measure measures length or distance. So my testable question will probably be, does the height of the ramp, 1 book, 2 books, or 3 books, affect the distance the car travels? Why? Because the height is the one thing I changed. Okay, now let's look at another investigation. Oh, this is getting fun. Can you spot the difference? Let's look. Here's my setup number 1, 3 books and bubble wrap in a car. Here's my ramp, 2 books, my car, my ramp, sandpaper. Wow. Let's go over here. Ready? 1 book, foil in the same car, plus my tape measure. What do you think about this setup? Would a good scientist do an investigation like this? I'm going to give you some think time to tell me what I just did wrong. You got it? Here, I changed the height of the ramp, 3 books, and the surface of the ramp. 2 books and the surface of the ramp. 1 book and the surface of the ramp. But any good scientist knows you can only test one thing at a time and change just one thing at a time. One thing. Everything else has to be the same. So what can I do to make this investigation, this experiment, scientific and right? I'm going to give you some think time. How would I change this up? Do you know? Okay, let's think. Can you see me thinking? Okay, good. I'm going to make everything equal except the surface. So I'm going to take away this book here. How many do I have? 2. And just change the bubble wrap. Here I already have 2 books. And I'm going to change the surface of the ramp. Keep sandpaper. Only thing that's different. Over here, I only have 1 book, so I'm going to take this book that I got from the first model, put it over here, and just change the surface of the ramp. Do you see its foil? Good. So let's see. The height of the ramp, is it the same? Yes. The ramp itself, is it the same? Yes. The surface of the ramp, bubble wrap, sandpaper, foil, it's different. Is that the only thing that's different? Yes. Even the car's the same because I'm using the same car over and over again. See? You're smart enough to spot the little difference. I couldn't trick you. Oh, I'm excited. Let me see if I could catch you. Let me see if I could fall into my trap. Will you fall into my trap? Insert maniacal laugh here. Okay, we gotta have close-ups for this. Let's look carefully at this setup. Look carefully. Come over here. Let's look carefully at this setup. Okay, now let's look carefully at this setup. How many of you spotted it? Shh. I'm going to give you some think time. What's the one thing I changed? Can you spot it? Are you the eagle eye? I know I got my GT scholars out there, my scientists out there, my STEM masters out there, my STEMicists out there. But I think I tricked you. I bet you can't find it. I'll give you some think time. I'm good. Let me show you what it is. Let's take a look. Look at how I arranged this ramp. Look how I arranged this ramp. Look at how I arranged this ramp. Ramps 1 and 3 are arranged the same way with the openings and the slits going up and down. Do you see that? But look at ramp 2. The slits are going side to side. Oh, that was tricky, Miss Ricketts. But you know, that's the kind of thing that might be on the test. You need to be able to spot the difference to see what they're testing. And remember, not only do I only change one thing, but I always make my grid, my data chart, because scientists repeat the investigation over and over and over again to be sure, to just be double sure, to be triple sure, to have accurate data. So we do multiple trials, repeated trials. Remember that. We just don't do things once. That's it. No, we want to be accurate. We want to have reliable information. Okay, so it's Miss Ricketts here. Have fun. I know you're entering Snapshot 1, my 5th graders. You can do it. You can spot the elements that are different and what stays the same and what we're testing and why we do repeated trials over and over and over again. So remember, Miss Ricketts is here for you, and the world is your laboratory. Now it's time for a little 3D to 2D transfer by playing quizzes. What is the one thing being tested? What is the one thing that is different? So let's click on the picture and see if we can find out. Here's ramp one book, the ramp in the car. 2 books, ramp in the car. 3 books, a ramp in the car. 4 books and a ramp in the car. The cars look the same to me. The ramps look the same to me. What's different is the height of the ramps, is they have different number of books in each ramp. Let's see what our choices are. The height of the ramp, the surface of the ramp, no, that's the same. The mass of the car, no, that's the same. The length of the ramp, no, that's the same. The one thing that's different is the height of the ramp. Next question. What is the one thing being tested? What is the one thing that is different? Let's click on the picture to make it bigger. I see I have 3 pictures here. The cars, let me look at the cars. They all look the same to me. The height of the ramp, 2 books, 2 books, 2 books, the same. The length of the ramp look the same. But this one has a surface of sandpaper. This one has a surface of foil. And this one has a surface that's wood. So the surfaces are different. Everything else is the same. Let's take a look at our answer choices. Is it the height of the ramp? No, that's the same. The surface of the ramp, they're different. Sandpaper, foil, wood. The mass of the car, they're the same. The same. The length of the ramp is the same. So the one thing that's different that I must be testing is the surface of the ramp. Yay! What materials are needed for this investigation? So let's take a look. Car, same. What do I need? I know the sandpaper and the surfaces are different. So I want to see if the surface of the ramp affects the distance the car travels. What measures distance or length? What tool would I need? Let's take a look. Do I need a hand lens to measure length, distance? No. A metric measuring tape? Yeah, that measures length or distance. Option. A thermometer? No, that's temperature, that's heat. So it wouldn't be that. A triple beam balance, that measures mass. So it has to be the metric measuring tape because of the length. It measures length. Yay! What is the one thing being tested? What is the one thing that is different? Take a look at the picture. I have car and a ramp again. Let me see if I can spot it. Ramps look the same surfaces, same length. The height here, 2 books, 2 books, 2 books. But here I have 5 grams, 10 grams, 20 grams. So the mass is different, but it seems like everything else is the same. Let's look at our answer choices. The surface, is that different? No, it's the same. The mass, is that different? Yes. We have 5, 10, and 20 grams. That's different. The length of the ramp, no, that's the same. The height of the ramp, that's the same. So the one thing that's different is the mass of the car. And I'm probably trying to test, does the mass of the car affect the distance the car travels? Why do scientists conduct investigations over and over and over again? Repeated trials or multiple trials? Let's take a look at the picture. Oh, we have a data chart. We have trial 1, trial 2, trial 3, and an average. So they're doing it over again. Let's look at our answer choices. To be sure, yes. To have accurate data, definitely. To double check, definitely. All of the above. Yeah, it's definitely everything here. Wow. So we were able to take our quiz is and transfer what we did with hands-on to 3D. That was fun.